morning. My name is Sean Senevaratna, and I'm a Regional Technical Manager here at Siemens Digital Industries Software, and I'm based in Singapore. At Siemens, we're all about helping you harness the power of digital transformation to develop better products, faster and more efficiently. Our aim is to bring the technologies of tomorrow to our customers today, and Solid Edge 2021 is a perfect example of that. But first, let's take a look at complexity. One of the main issues we see today is that manufacturers are faced with increasingly complex requirements from customers, from emerging technologies, from competition, and even regulations. And these complexities can be seen across all industry sectors and from small manufacturers to startups. So here is a customer that we worked with, an automation manufacturing and engineering firm based here in Southeast Asia. They design complex machine heads for robotic arms that you see in the picture, and they perform all sorts of tasks: assembly, welding, testing, and so on. They face several business challenges. First of all, complex designs. As you can imagine, the designs are extremely complex, and also there are a high number of components in their machine heads. These components are not simple either. They're very precision parts, so it means that issues of interference, both static and dynamic, need to be taken into account. They work with large number of files, not just from one firm. So putting them together and making design changes on these imported parts was very important. And of course, there was the time pressure of being delivered first to market. The fact is that digital transformation has never been more accessible and affordable for small manufacturers. Digital is leveling the playing field for businesses of all sizes, including SMBs. And a large size company, which was once seen as a competitive advantage, can actually become a liability. Smaller companies can be more nimble and adopt new technologies faster. So digital transformation actually represents a tremendous opportunity for small manufacturers. Now, at Siemens, we believe that a key to addressing the challenges around increasing complexity is the digitalization of the product development process, this workflow that you see, all right? And a key building block for digitalization is to create the digital twin, a detailed 3D model of your products, which can be used as a basis for all areas of product development, including managing customer requirements, concept and detailed design, prototyping, simulation, manufacturing, installation, and servicing. Now, it's very important to understand that Solid Edge is more than just a CAD system. Sure, it's got mechanical design, right? But in our increasing portfolio, you'll see that there are other pillars. Mechanical design is just one of the 7 pillars that we have. Electrical design, simulation, manufacturing, they're all part of the Solid Edge portfolio, along with technical publications, data management, and cloud collaboration. I will be going through some of these, and the other speakers will be tackling them in the other sessions as well. Let's start with a mechanical design. Our aim is to focus on what, not just the how. A lot of other software systems out there will force you into a very rigid way of working, especially with history-based modeling. What that means is that they take a feature and build another feature on top of it and another feature on top of it in a very specific sequence. And if you were to make a change to one of their features, it might actually affect the other features and errors might result. We don't believe in that. We believe in working the way you think. So we put usability and flexibility at the top of the list. For example, we have design intent, which is a sort of artificial intelligence that looks at how you have designed their parts, you design your parts, and it adapts to the way you design it. If you want to make a design change, for example, it will detect if a part is symmetric. Dimensions. We don't force you to put dimensions only in 2D sketches. Dimensions could be in 3D, and they will drive your design as well. How about design changes? Now, if you were to want this vertical area to move by 5 degrees, let's say, it's very simple in Solid Edge. All you need to do is highlight that area and push it by 5 degrees. This would be something that's impossible in some other systems. Let's take a further look at design changes. We have a fuel tank over here. We want to change this feature because the geometry around the fuel tank has changed. Let's see how this is done in history-based modeling. We make a change, but we realize that it actually affects some other features, and that's not good. So we actually have to, start to play around and re-edit features here and there. And as you can see, this takes more than a minute. In Solid Edge, it's very simple. You just select what you want. On the fly, you can change the relations and you can see the result. 17 seconds versus over a minute. That's a huge time saving. And it doesn't just work for one component. Multiple components within an assembly can also be changed at the same time. How's that for productivity? And then when it comes to working with imported geometry, here is a 2D drawing. We can transport it into Solid Edge and put it in a 3D environment. Not only that, using Solid Edge's technology, we turn it into a 3D object, and as you can see, the dimensions are automatically read in. But that's not even the end. If you want, you can make a design change, and it'll be as easy as if you designed it in Solid Edge yourself. 3D parts can be read in just as easily, but again, that's not the end. The proof is actually in making design changes. So here you have a flange being changed, right? Not only that, you decide you want to move the gearbox and motor a little further away, you can. Again, these are parts that are not designed in Solid Edge. You don't even know what features there are, and yet making design changes is so simple. How about large assemblies? Here we have a very large assembly. As you can see, it's over 2 million parts. What is it? It's a cruise ship. So you can see opening, moving the cruise ship around, not a problem at all. This is something that a lot of other systems struggle with. But again, because of our technology, it means that performance is going to be a lot faster, which means faster time to market. Now, moving on to manufacturing. This, of course, is important because it means that you're finally bringing your designs to life. Now, here we have an aerospace part with an undercut. With Solid Edge Cam Pro, we have multi-axis roughing using adaptive milling. What this means is that your milling can be done faster, and at the same time, you can have longer lasting tools. If you notice, the tool actually swings to achieve the optimal cutting angle. Simulation can be done both as toolpath based simulation, but that's not so accurate. You can also have G-code based simulation, which actually uses the actual G-code to see exactly how the machine will be cut. That's a lot more accurate. Then you have your post processes. We have a post hub, which allows for easy finding of post processes online based on, say, controller, number of axis, machine maker, and you just download the one that you want. CamPro will install the post, and you get the result that you want. Now, many parts, many components are done also in sheet metal. And for sheet metal, we always want to optimize the use of material. So we have 2D nesting, which allows for that. All you do is you read in these sheet metal parts into our 2D nesting solution, and you just pick out the size of the sheet that you want. 2D nesting will automatically optimize the use of that material. As you can see, the number of sheets used gets smaller and smaller because it's rearranging those files so that you have less wastage of material. When you're done with that, you can read everything back into Solid Edge. Now here's a comparison with some of our competitors, competitor A, competitor B, and you can see the wastage of the material in those other competing software compared with 2D nesting. Now, when it comes to your products, you always need to document it, be it for maintenance manuals or for assembly manuals or for even marketing materials. Well, usually that is done in, say, Microsoft Word or Excel, but there's some problems with that. First of all, the images that you have are still images. You know, if someone wants to take a look closer or at a different angle, that would be impossible. Secondly, when your products change, well, your entire documentation is immediately outdated. So for technical publications, we have made something very, very interactive. As you can see, by clicking on one button in Solid Edge, it automatically pulls all your model into our documentation where you see templates that are ready-made, where you can create, let's say, an assembly. So here we show you in an animation how bottles are put together, how it works. You can see, okay, this is how, you press this button, the bottle comes down. Well, that's nice. You can also have an interactive bill of materials where just by selecting on a part in a bill of materials, it highlights the actual part in your view and vice versa. And as you can see, if you want to, you can actually interact with it. You can look at it from another angle, view it closer, so on and so forth. And by outputting as HTML5 and 3D PDF files, it also means that you will be outputting it in formats that everyone can read. Now, so with technical publications, it means that you're actually creating documentation that surpasses expectations with interactive and up-to-date documentations. Now, collaboration shouldn't just exist within your company. How about with suppliers, with your customers? This is where Solid Edge's cloud collaboration comes in. Our Solid Edge portal is a website that anybody, not just people with Solid Edge, can create an account and share designs immediately. So you can see people can view it in all sorts of angles, can create section cuts, can easily create comments. So this actually increases the collaborative aspect of talking with one another. They can also take dimensions to see distances between objects. So what that means is that all this information that you are sharing can be shared back and forth very easily, no matter where your customers or suppliers are in the world. Not only that, but we go a step further. You may have heard of augmented reality. What has that got to do with mechanical design? Well, you can share your designs with anyone and they can view it on a tablet or even a phone, see how their designs will look maybe on their shop floor or even maybe on a kitchen in the case of this juicer. So they will see, okay, this is where it fits. They can check for clearances, and all of this means that they are better able to make design decisions. So back to our customer that we talked about, right? We worked with them and made sure that they were successful. How? What were the keys to this success? Well, first of all, you had Solid Edge, a CAD system that can handle drawings, components with high complexity as well as a large number of parts. It was very easy to use, fast to create your parts, your assemblies, as well as to simulate your model. The ability to import and modify designs from other CAD systems was also very important. And then, of course, there was the support from our trusted Siemens partners. So what are the results? Basically, it means that there's faster design, modeling, release, of manufacturing drawings that meant a new level of engineering productivity was able to be achieved. And importantly is the ability to focus on design and not just operating the CAD software. Here you see some of our other customers. You might recognize a few of these logos. Now, this is by no means an exhaustive list of our customers. In fact, our customer base comes from all sorts of industries, from industrial machinery to oil and gas to healthcare, to even automotive suppliers, for example. And so you can see that we serve not just a wide range of industries, but also a wide range of size of customers, from big to small customers. Here is one more case study. This is a tool manufacturer by the name of Sharp Chucks. Their challenge was basically to simplify a complex design process to better serve their customers, and also to migrate from a combination of 2D and 3D environments to a completely 3D design environment. Now, how did we do that? Okay, basically the solution was that we moved them from a combination of 2D and 3D to Solid Edge, which could handle these multiple formats very, very easily. And using our synchronous technology, we're able to quickly edit these files. What does this mean as a result? Well, manufacturing costs was cut by 15%. Engineering design productivity was increased by 20%. Design cycle time was reduced by 35%. And this is something that's very important. There's assembly errors that was reduced by a very, very large 50%. I started this presentation talking about the explosion of complexity. Now, this can be difficult for anyone to manage. Our message is, don't try to reduce complexity. It's not going to go away. So instead, be the disruptor. We provide solutions to make decisions with confidence, to move faster, reduce costs, create new business models, to out-innovate your competition and be the leader. New insights, new opportunities, and new efficiencies exist at every point of the value chain. These are the promises of tomorrow, today. Thank you very much.